Hey everyone, and welcome. Today we are pulling back the curtain on AI, but we're not going to talk about code or algorithms. Nope, we're talking about the massive, often invisible, human systems that are absolutely essential to make AI smart, safe, and reliable. All right, let's get into it. I mean, have you ever really stopped to think about it? You ask a chatbot some ridiculously complex question, and boom, you get a coherent answer back. Or you use a translation app and it's pretty much spot on. It really does feel like magic. But here's the secret. Behind that magic is a hidden army of people. And figuring out how to manage that army, well, that's one of the biggest puzzles in AI today. And this right here, this quote gets to the very heart of the problem. It's a total paradox. Think about it. A small team of, say, 5 experts checking AI responses, that's easy. You can all talk, stay on the same page. But what happens when you need 500 people or 5,000? The very thing AI needs to get better, human evaluation at scale, is the thing that can cause the whole system to spiral into chaos and for quality to just completely collapse. And this is the key. You can't just throw more people at the problem and hope for the best. That's a recipe for disaster. The real solution is to build a smarter system, a well-oiled machine that's designed from the ground up to maintain quality at a massive scale. We're going to call it a quality engine. So here's our game plan. We're going to build this engine together piece by piece. First, we'll tackle that core scaling problem. Then we'll assemble our dream team. After that, we'll build an automated defense system, learn how to fight off the inevitable decay of quality, and finally, we'll see how this whole thing works in a real-world scenario. Okay, so let's start with that central challenge, the scaling paradox. It's actually pretty simple when you break it down. With a small team, communication is easy. You can check in on everyone, everybody knows the mission. But once you have hundreds of people, maybe all over the world in different time zones, well, keeping that consistency becomes pretty much impossible without a super robust system. So, the very first part of our quality engine is the people. But it's not about just hiring anyone who can fog a mirror. It's about being strategic. It's about creating a structured 3-tiered workforce. The big idea here is simple but powerful. Match the right person with the right skills to the right task. And this is the perfect way to think about it. Imagine a high-end restaurant kitchen. You would never ask your superstar executive chef to spend their entire day just chopping onions, right? And you definitely wouldn't ask a brand new prep cook to create the signature dish for the evening. Every role is crucial, but they're specialized. The exact same principle applies here. Now let's look at how this kitchen is organized. Up top in Tier 1, you've got your executive chefs. These are the domain experts, doctors, lawyers, engineers, who handle the trickiest, most nuanced tasks. They're aiming for near-perfect accuracy, over 95%. Then in the middle, you have Tier 2. These are the line cooks, the trained specialists who are the backbone of the operation, handling the bulk of the work. And down at Tier 3, you have your prep cooks, the crowd workers who tackle the high-volume, simpler tasks. Each tier has its own job, its own accuracy target, and its own pay scale, which all works together to create this super efficient, cost-effective system. Okay, teams assembled. Awesome. Now we need our second component, an automated quality control pipeline. Look, at this scale, you just can't have a human manager checking every single piece of work. It's physically impossible. So you build a machine to do it for you, a kind of high-tech watchdog with 5 different layers of defense. So how does this watchdog work? Let's go layer by layer. First up, you've got the gatekeeper. It does a simple check. Is the work even finished? Basic, but essential. Layer 2 is the detective, and it's looking for logical contradictions. Like, you can't rate something perfectly accurate, but then also flag it for having misinformation. That doesn't add up. Layer 3 is the undercover test, where we sneak in questions that we already know the answers to. We call them gold standard items, just to see if people are paying attention. Then there's the profiler, which uses stats to find weird patterns, like someone who just rates everything a perfect 5 out of 5. And finally, Layer 5, the obvious case. We inject super easy honeypot questions to catch anyone who's just mindlessly clicking buttons. All right, we've got our team, and we've got our watchdog. But here's a secret that anyone in a large-scale operation knows all too well. Quality isn't static. It goes down over time. People get tired, they get a little too comfortable with the task, and their judgment starts to drift. So the third piece of our engine is a system to actively fight this quality decay. Now, our main weapon in this fight is something called statistical sampling. You see, you can't review every single piece of work your team does. It's just not feasible. But the good news is, you don't have to. By scientifically checking a small but representative sample, you can get a surprisingly accurate picture of the quality of the entire workload. It's the science of checking a few to understand the whole. So how do you actually do it? Well, you can start with a simple rule of thumb like the square root rule. If you have 10,000 items, you'd manually review the square root of that, so 100 items. Pretty simple. For more critical stuff, like, say, medical AI, you'd use risk-based sampling, where you check a lot more because the stakes are so much higher. And for the most efficient system, you use stratified sampling, which makes sure you get a balanced check across all your different people, task types, and even times of the week. And this shows you exactly why all that sampling is so important. Because quality degrades in a predictable way. For the first week or so, everything's great. People are fresh. But after that, fatigue and, just being too familiar with the task sets in. By week 4, you can see a real, measurable drift in quality. And if you go more than a month without doing anything, the data can become systematically unreliable. The trick is knowing this is going to happen and planning for it, with things like monthly retraining sessions to keep the whole team sharp. Okay, we have seen all the pieces of our quality engine: the tiered team, the automated watchdog, and the sampling strategy. So now let's put it all together. Let's fire this machine up and see how it actually performs in a real, large-scale operation. So here's the mission. A big company needs to analyze a mountain of customer feedback to make huge product decisions. The stakes are really high, so accuracy is everything. They're going to deploy our 3-tier system to process all of this feedback. And what kind of scale are we talking about? They are processing 50,000 pieces of feedback, not per year, every single month. This is a serious operation. So, what does a quality engine like this cost to run at that scale? $156,000 a month. Yeah, that number includes everything: the pay for all 3 tiers of workers, the software, the management, the whole quality control infrastructure. Quality at scale is a serious investment. But here's where it gets interesting. When you break it down, the cost becomes really tangible. It costs $3.12 to process each individual piece of feedback with this robust guarantee of quality. And knowing that number, that's what lets the company make smart decisions about where they're putting their money. So the big question, was the investment worth it? Oh yeah, absolutely. The system hit a super respectable 88% accuracy across that entire massive volume of data. And for the really critical stuff that got kicked up to the Tier 1 experts, an incredible 96% accuracy. The engine works. It just plain works. So if there's one thing to take away from all this, it's that reliability in AI doesn't just happen. It's not magic. It's the result of meticulous engineering. It's a deliberately, carefully designed system that brings together people, automation, and statistics in just the right way. So to recap it all, if you want quality at scale, you have got to structure your workforce into those 3 tiers. You need to put all 5 of those automated quality control layers in place. You have to use statistical sampling to watch out for quality decay, and then you have to actively manage that decay over time. And finally, you have to know your costs. So we've just taken a deep dive into this powerful human engine that makes our AI reliable. It's pretty amazing stuff. And I'll leave you with this question to chew on. As AI gets more and more powerful, what does this massive, hidden, and deeply human effort behind the scenes really tell us about the true nature of artificial intelligence and where it's all headed?